Almost. Always some technical difficulties. Oh. Is it on now? Yes, it is. Nice. Now I can start. I would like to start by introducing you to someone. His name is François Aytagivas. In 1807, he was the inventor of the first hydrogen car. More than 200 years later, the first commercial hydrogen car was introduced by Hyundai. Now, I'm gonna ask you a question. Do you think that it's possible that a group of 26 students is capable of building a racing car on hydrogen in less than a year? Think about this question. In the meantime, I want to welcome you. Welcome to the car review of Green Team Twente. Thanks for being here. During the upcoming presentation, we are going to show you that it is possible. It is possible to build a racing car on hydrogen in less than a year. Together with the rest of the team, we're going to show you our car. We're going to tell you our journey and all our ups, but sometimes ook downs. And after that, Torben is going to tell you all about our summer. Because, of course, we are not there yet. We have still some few weeks ago where we have to work really hard to get our baby driving. After that, Torben is going to tell all about the Formula students, which we are going to participate in. And Mom, I don't know where you are, but now I hope you know why I'm not joining on holiday this year. But I want to go back at the beginning, when the first car was invented. After 2 years, the first car on gasoline was invented and a lot has changed. In 2019, 67 million cars were produced. That is almost 2 cars per second. The total car industry makes up for around 50% of the total carbon footprint. That's a lot. And I think, and I hope you think it as well, we need to change it. I was asking myself, how could I be part of the solution? How could I be part of solving the problem? And I have to imagine, I have to admit, I would have never imagined that I would find it in this group of enthusiastic students. But of course, we were not the first ones. We are now building a racing car on hydrogen and competing in the Formula students. But one thing is still the same. We still want to push the boundaries of the current hydrogen technologies in the automotive industry even further. This year, we are going to show our end result during the Formula students. I want to welcome Torben on stage to tell you all about it.
My name is Torben and I'm the technical manager at Green Team Twente. This year we are participating in Formula Student. Sounds fancy, but what is Formula Student? Formula Student is an international competition held annually across the whole world. More than 400 student teams participated in it across the whole world. Formula Student competition consists out of several events. During these events, a team can score points, and the highest overall score wins Formula Student. First, I'll tell you a little bit about the dynamic events, in which the performance of the car is shown. First, you have the acceleration event. In the acceleration, it's a track width of 75 meters, on which you start standing still and accelerate as fast as possible. The really fast teams do this within 4 seconds and end up with a velocity of higher than 100 kilometers an hour. The next event is the skid pad, in which the teams drive in a figure of 8. This figure of 8 is done as fast as possible and shows really the cornering of the car. The next event is the autocross. The autocross is held at a karting circuit made even narrower with some cones. And it really tests the acceleration, braking and cornering of the car. After this, you have the endurance event. The endurance event is actually the same as the autocross event, but then for 22 kilometers long, really showing the longevity of the car. In Formula Student, it is actually really impressive if a car finishes the endurance event, and this is why it's worth so many points. During the endurance event, also the efficiency is tracked. The efficiency is tracked by taking it relative to the speed. Good points of that. Formula Student is an engineering design competition, and it's not only about the performance of the car, but it's also about other aspects, in which the engineering and design is judged. You have to hand in a report beforehand, showing your engineering and design choices of the car, discuss this with the judges and get points based on that. You need to show your costs and manufacturing of the vehicle, and being judged on that, why you chose a certain time of manufacturing, or why you chose to manufacture it instead of buy it, or to buy it instead of manufacture it. And then you have the business plan. The business plan is to present your product and really convince everyone that you have a good product and get points off of that. Now here's a picture of Formula Student Germany 2022. You can see our big chunky green car in the bottom right. And it's a little bit chunky because it's the only vehicle there that is driving on hydrogen. And a lot of additional parts are necessary for that. This is why it's a little bit bigger. And Formula Student Germany is the unofficial World Championship of Formula Student. And 100 teams compete in this yearly. Currently, there are 2 options of participation. There is a combustion vehicle class and an electric vehicle class. The organization has announced that in 2024, the combustion class will be removed from Formula Student. This gives the teams 2 choices. Or they do not participate in Formula Student anymore, or the second option, they join the highly competitive electric vehicle class, which exists for more than 10 years. We as Green Team Twente want to introduce a third option. We would like to create a hydrogen Formula Student class in which teams can build a hydrogen Formula Student car and race against each other, creating more innovation in the hydrogen automotive industry. We are participating in Formula Student Germany 2023, showing the world that making a Formula Student car on hydrogen is possible. And we have this proof with us here today.
But of course, how did we come up with this name? Apollo is a space mission of NASA. And during the space mission, they used a rocket that runs on hydrogen, just like our car. And they were successful by putting the first man on the moon. Like them, we are going to be pioneers as well. We are going to be the first ones to drive on hydrogen during the Formula Student. There was a second reason. Last year, they called their car Gemini, and Apollo is the one next coming in line for the space missions. Now, I want to welcome Boris and Jeroen on stage to tell you all about the technical specifics of the car.
Hello. Well, the car looks very cool, but I'm sure you're curious to see what's inside. My name is Boris, I'm the Chief Mechanics, and this is Jeroen, our cooling systems engineer. We're going to be telling something about the technical aspects of our car to make sure you get a better understanding of what we actually have been doing this year. Well, as Amber already told you, the goal of Green Team Twente has shifted from driving as far to as fast as possible. And with the knowledge gained in the Shell Eco Marathon time of Green Team Twente, last year's team started their journey in making a Formula Student car. And we have the privilege of continuing that. But what has actually changed during the last 2 years? Well, we went from a fuel cell power output of 0.14 to 10 kilowatts, which is almost 60 times as much. Our hydrogen capacity increased from 14 to 300 grams, and our maximum velocity went from 35 to 75 kilometers an hour. And all those changes result into this car. But what did we do this year? How did we do it? Let's start off with the mechanics. Monday morning after the summer break, all still a bit tired from the fun team weekend we had, we started and we didn't know what to do. We looked at each other and said, well, what now? So we started discussing what the old team had in store for us, for example, implementing four-wheel drive. We discussed it a lot, but came to the conclusion that we would only be doing about half of it, what they said, because we wanted to finish our car in time. Well, once that was finished, we started with the design phase, which is very scary, but you just have to get on with it. And then in no time, it was already Christmas break, and our first iteration of design was finished. Then after the Christmas break, with the renewed energy, we went to the office again and looked at our planning. We were a bit shocked, because we only had 1 month left to finish our second iteration of the design, and that's just a fancy word for final design. While in the meantime, our hydroelectric assembly still looked like this. This is not nearly ready to be put in a car. Well, we worked on, and once the stress had calmed down and we handed in our designs, we could continue on to the next phase, construction, which is very fun. Slowly but surely, all components started to come in, and we started assembling the car. But then around 3/4 into the year, a group of driving instructors visited our office, and we showed them our hydrogen test setup table. We talked about it, and we explained that all components, which as you can see at the back later, had to be gone into our car in only 1 month time. Well, in disbelief, they laughed at us and asked us if our car would be pulling a trailer along. And offendedly, we said, no, of course not. But deep down inside, that stupid comment of the driving instructor made us realize we still had a long way to go. Well, but then, how do you build a car? Let's start at the base, the chassis. That has been made by Jurian and Matthijs this year. They have worked this year very hard to fit all components as safely and efficiently as possible in the car. And their main challenge was actually the whole hydroelectric subteam, because their components had the weird tendency to change shape or size or appear out of nowhere before disappearing again, which makes the assembly of your car a very big challenge. And then you also have the needs of the mechanics, which are hard. Aerodynamics wants a very slim and sleek chassis design for minimized drag, while vehicle dynamics want a certain A-arm placement and a large track width for good stability. Well, eventually we ended up with this beauty of a chassis. The chassis itself weighs about 1 whole. Matthijs, our structural engineer, which is 84 kilograms. It's 3.4 meters long and 1.4 meters wide. And those numbers don't say a lot to you, but it actually has the same length to width ratio as a Porsche 911 and an Aston Martin Vintage, which is very cool for a race car. But unlike those sports cars, our chassis has been made from steel tubes, which are welded together at VDL Special Vehicles. And Matthijs and Julian, after that, they brought it to the hangar at the university to do some post-processing. And they worked very hard grinding, welding and burning away at the chassis to make it all finish in time. And then, how do you get the chassis on the road? Well, that's the job of the vehicle dynamics sub-team. Minz and Francesco had worked this year to build a suspension setup, and they were having to make trade-offs between grip, durability, ride comfort, and weight, for example. Well, in the end, they are responsible for the handling of the car. But how did they do it? At the base of our suspension system, we have aluminum knuckles and hubs, which are attached to the chassis with steel A-arms. Once you get your car up to speed, you should think about how you stop it. And for that, we designed a custom floating brake disc design system, which you can see here. And all the performance has been put on the road by 10-inch racing tires and a direct suspension link to the chassis. And at last, the vehicle dynamics sub-team has built a custom steering system. Then I have a question for you. You probably noticed I said the word custom a lot when talking about vehicle dynamics. So if you can all get your cards out that you got in your goodie bags at the beginning of the show. Okay, then the question. Does our suspension system contain more or less than 100 custom built parts? Show your green cards if we have more than 100 custom built parts and your red cards if we have less. I actually see only a couple of red cards. It's indeed green, of course. We have 116 custom built parts in our suspension setup alone. And now the words on to Jeroen.
Hello everyone, my name is Jeroen. I'm a cooling system engineer within Green Team Twente, and I'm going to tell you what makes Green Team Twente Green Team Twente. And that of course is our hydroelectric system in a car that distinguishes us from other student teams. But first I would like to start off by telling you a bit about how we developed this hydroelectric system. Of course we are on a limited budget. So this means that the smarter we are and the more we can reuse fancy testing equipment or the less testing equipment we need, the better the racing performance of our car will end up. I should state, however, that quality and safety are still of utmost importance to us. But science doesn't have to be pretty, it has to be effective. As for my own experience, at the beginning of this year, I needed a large amount of hot water at a temperature of 70 degrees in order to test our radiators. Not that easy to come by. Fortunately, my parents were doing some home renovations at the time, and their ultra-electric water boiler was no use to them anymore. So, with great thanks to them, my dad brought the thing to Enschede, where it now serves a second purpose in my radiator test setup. As you can see here. As for the car we have developed this year, it is powered by two rear-mounted electric motors. They are electric because we are secretly an electric vehicle. But unlike an ordinary electric vehicle, we don't take our electricity from batteries, we produce it ourselves on board with a functioning hydrogen system. The motors are then controlled by a special motor controller developed by Niels for optimal racing handling of the car. For quick startup and acceleration, Chris has developed an electric accumulator together with Super B and its function is to absorb all the spikes and drops in current demand of the car which the fuel cell cannot supply. In the heart of our hydroelectric system sits our fuel cell. This is the component where the reaction between hydrogen and oxygen actually takes place to produce water, electricity and heat. It does this with a stack of 215 cells, many of which have been adopted by the names on screen, for which we are very thankful. On one side of the hydrogen system sits a compressor system that takes air from the atmosphere and treats it to the right pressure, humidity and temperature for optimal performance of the fuel cell. On the other side sits our hydrogen tank, which also treats this fuel to the right pressure, humidity and flow rate. At the beginning of this year, Sarah and Marnix developed a test table that you can see in the middle of the audience over there, while the rest of the car was still being constructed with the help from Demcon. It facilitated a high degree of modularity and safety when testing single components or the hydroelectric system. Unfortunately, I have to admit to you that driving on hydrogen is not 100% efficient. And in order to prevent the fuel cell from overheating, we have to cool it down. So, I would like to ask you, which of these two cars has a greater cooling performance under similar driving conditions? Show a green card for our car and a red car for the Porsche 911. Okay. I again see a lot of green, which is true, as can be clearly seen by the large air ducts that are on our car. And in order to cool down the fuel cell, we pump deionized water through it at a rate of 90 liters per minute. This has to be non-conductive water because of all the high voltages that the fuel cell creates. This water is then fed through our radiators, where aerodynamic features of the car provide enough airflow through the ducts to dissipate this heat to the outside air. The fun thing about our cooling system is that it's actually two cooling systems, because the fuel cell demands such a high cooling performance and non-conductive water that all the other components are combined in one cycle that only account for 3/10 of the entire cooling capacity of our car. And because we are interested in the best racing performance of our car, Bram and Arjan have developed our own control systems in the car with help from Syntax. Their function is to monitor, log and adapt all sensors and components in the car. Now, to get a feeling for how complex this task is, I would like to ask you, do you think there are more people in this room than sensors in this car? So if you think there are more people in this room, show a red card. And if you think there are more sensors in this car, show a green card. Have a look around you. We might be giving away the color with green team, but it is again green. There are approximately 600 sensors in this car. And with this great control system, we hope to be in great capability to analyze the performance of our car during testing, and for next teams to improve the car based on the framework that we have built together as a team this year. As of the beginning of this year, we did not possess such a nice control system. And when testing and developing single components in the car, we often use micro development boards like Arduino. Great for testing single components, but when integrating them all into one big system, it can quickly turn into a wire spaghetti. And as a consequence, some afternoons were spent head scratching and talking about complex interference. An experience we hope our next team won't have to experience because of all the great technical solutions we have built this year. And now to wrap up, Boris will talk a bit about the appearance of our car.
Okay, the last sub-team of our of Green Team Twente, aerodynamics, which are the show ponies of our car. Jasper, Aditya and Pepijn have worked this year on finding the perfect balance between minimizing the drag and maximizing the downforce of our car. And to make it even more difficult, they made it all from carbon fiber. Well, the design phase of the aerodynamics team goes hand in hand with computational fluid dynamics. This is a technique to simulate and analyze the airflow going around your car, and this is used to get to our first goal of aerodynamics, which is minimizing the drag of the car. And this has been done by the body. The body has been produced at the Dutch Aerospace Engineering Center, and accompanied by me, we spent 3 weeks in a caravan in Marknesse, and that's somewhere far, far away in Flevoland, and we worked very hard over there. We had a tough time. Then the second goal of aerodynamics, which is maximizing the downforce. This has been achieved by building a front and a rear wing, and at 75 kilometers an hour, we produce about 1100 newtons of downforce, which is the same as Van Hoort Torben, our technical manager, sitting on the car while driving. Eventually, after a bit of nose surgery done by Pepijn, a bit of designing skills by our communication team, and some post-processing done by Frank Geerlings, we end up with this beautiful aerodynamic livery. And then, all in all, in 2 years' time, we've almost built a functioning hydrogen-powered race car. In the near future for Green Team, there are lots of things to be improved, but we have laid a good foundation of which we can be proud of. We hope to have given you enough insights into our hydrogen-powered race car, and we wish the new team good luck in making our car even faster and accelerating the adoption of hydrogen-powered racing. And now for the last words, Amber and Torben.
Formula Student Netherlands will take place in 2 weeks' time. At this event, we will show what hydrogen can do in the automotive industry. Formula Student Netherlands is an open event to visit, and it takes place from 8th to 13th of July. We recommend to join the 12th or 13th of July, as though most likely the autocross and endurance races will be held there, which are most fun to watch. We hope to see you there.
For now, I want to thank you all for being here. And a special thanks to our partners, which without them, it wouldn't be possible. We wouldn't be able to build a racing car in hydrogen, and we wouldn't be able to show the world all the possibilities hydrogen has to offer. A special thanks for our communication team and Timo for creating this event. And thank you Hugo for setting up this live stream, and thanks to Schouwburg that we can be here and with our event. For now, there's one last thing to do. I want to go back at the question I asked you at the beginning of the presentation. I hope we convinced you that it is possible. It is possible that a group of students is capable of building a racing car on hydrogen in less than a year. Now, I want to welcome all those hardworking students on stage and give them a big applause.
Ja,